The truth is, some people will want to know if they got certain questions correct on the exam. I will be writing the exam, I hope, and submitting it. So I won't have a physical copy of my exam. But if you want to, you can come and talk to me in period E tomorrow afternoon, and I will have written the same exam as you. And if I have an extra copy of one, which I might very likely, we can look at any question if you're worried about what you did on that particular question. So it's up to you tomorrow afternoon. If you want to go home and celebrate that you're done high school mathematics, you can do that. If you want to suffer a little bit more and look at some of the questions from the exam, you can do that as well. It's up to you. It's also the last day of official classes. I'm sure most of you have exams that you need to prep for other than math. So use your time wisely. Do you want me to find an exam for you to prep for? That sounds like a dad thing to say. Did you? Why would you do that to yourself? Oh, so it was a personal thing?
Yeah.
Can I ask this question? I don't know if you guys will answer this. How many of you have completed? Oh, why don't we do it this way? Okay, everybody put your arm up. Everybody put your arm up. Everybody put your arm up. Jason, Alan, put your arm up. Okay, you ready? How many have, so you only bring down your arm if your answer is no. How many of you completed one exam? Keep your arm up. Okay, how many have completed two exams? Uh-oh. How many have completed three? Wow. How many have completed four? And then how many have completed all five? That's pretty good. Oh, Jacob's here. That's pretty good. All right. Here's this question's come up a few times. Yeah. Say that again, please, Dorsa. Yeah. Sure.
I'm not right.
That's fine. That's fine.
Sure.
Alina. This question has come up quite a bit. Hi, Jameson. Glad you could make it. I know I did this on the exam. So this is one of the mistakes I made in the past. I'll show you what I did, just out of bad habit. And then we can talk about why what I did was wrong. Shh, we got lots to do. So I was looking at this, I was moving quickly. I went, oh yeah, this is no problem. This is n minus 6, followed by n minus 5, followed by n minus 4 factorial, all over n minus 4 factorial. Look at me, I'm doing a great job. Final answer is indeed what you see up top. Why is this wrong? No, it has nothing to do with 0 in the bottom. I like what that someone said. I'm going the wrong way. Because if you think about it here, if n was 10, wouldn't this be 10 minus 6, or make it even bigger? Let's say if n was 12, wouldn't this be 12 minus 6, and wouldn't this be 12 minus 5? This would be 6, this would be 7, this would be 8. Is it supposed to go up? No. So the true way you're supposed to answer this question is recognize it goes in the following manner. Leave the n minus 6 alone because n minus 6 is the smaller number over n minus 4, which is bigger, multiplied by what is 1 less than n minus 4? N minus 5. And what's 1 less than n minus 5? Okay, and now we can cancel. Now can we see what the answer is? Okay. Thank you for asking. Better? Okay, all right. We've seen this particular identity before. As usual, there's often an identity. Try that again. Just creating new words. Often there's an identity near the end of the second booklet. In fact, there's usually one in both booklets. Okay. This one looks like which type of identity? Wait a second. We don't even have to do the identity. What is it asking us to do? So what does verify mean? Just do what? Just plug it in. So it doesn't even ask you to do the identity. It just says verify. Shh. So if it just says verify, don't do the identity. Honestly, just everywhere you see X, you'll replace it with, and then you just do both sides separately. So on the left side, it's going to be the cosine of 5 pi by 6 over 1 minus the sine of 5 pi by 6. Going to remind you, what is the cosine of 5 pi by 6? Perfect. So minus root 3 over 2. 1 minus, what is the sine of 5 pi by 6? Hopefully it's positive 1/2. And then can you just organize your fractions accordingly? I'm going to kind of do it all in one step if it's okay. It's going to be the minus root 3 over 2. And then you're going to end up, I'll just do it properly then. Is this not positive 1/2 downstairs? And then we now know then if you're dividing by a fraction, you multiply by its reciprocal. At the end of the day, is this minus the square root of 3? So we've just verified, we haven't even verified, we just found the value of the left-hand side. Now, can we do the same thing on the other side? So on the other side, it's going to be 1 plus the sine of 5 pi by 6 all over the cosine of 5 pi by 6. We're expecting that it should be the same. So it's 1 plus 5 pi by 6 is still positive 1/2. And then downstairs, it's going to be minus root 3 over 2. So it's just 1/2 multiplied by the reciprocal, which is weird because doesn't it turn into minus 2 over the square root of 3? Which really doesn't look like the same, does it? Except, what do you think we have to do with this fraction that we've just generated? We're going to rationalize it, yeah? Not this week. And not next week. You guys, I'm going to have to buy a lot of shirts. Is this not 3 over 2? Better? And then this is now going to be positive or minus 3 over the square root of 3. Thank you for pointing that out. And then when we multiply by the reciprocal, or sorry, when we multiply by the conjugate, you notice that this is the conjugate. It should make minus 3 roots of 3 all over just 3. Now, are they not the same? Thank you for noticing that. That's all you need to show. Is verify better than for all possible values? Because that's what an identity is, right? It's not a proof. No. Nothing. You know what, if you want to do this, better. Not like testified, but verified. Next. So this looks like a remainder theorem question. Careful. It tells you that x plus 1 is a factor. So you need to know right away that means p of minus 1 must equal 0. Right? That's what it means to be a factor. It means the remainder is 0. That means you can take the minus 1 that you see here and change it for all of the x's that you have, and you know that this has to be 0. So our polynomial is equal to 0 when we put minus 1 in for x, which we cube. Then we put -1 in and we square plus k times -1 minus 8. Can you see the connections here? And now we've created a single equation with one variable. Please be careful tomorrow. Take your time tomorrow. You got 3.5 hours if you need it. -1 to the power 3 stays as -1. Be careful with this. It's -1 squared, which is positive, but then changes to negative. Then it's -k minus 8. And then you're just going to find out that k itself is equal to -10. Yes. So just so that we're clear, Mr. Kaminsky and I will be here a little bit before 8 a.m. because we have to set up the test site since there's over 90 of you writing. When you get into the test site around 8:25, 8:30, you will find a piece of paper. It's called a demographic form. So it's your personal information. It already has your name typed into it. So you'll find a page with your name already typed. And the most important thing for you is you're going to have an exam booklet number. You have to put the booklet number with your name. It's the only thing that connects you to your booklet. Okay, are you listening to me, Sam? Okay. And then once the exam begins, you have 45 minutes with booklet 1. And in fact, I never take booklet 1 from you. After 45 minutes, you'll put your calculator down on the floor. And then I will give you your second booklet. And most of you will still need probably another 20 minutes or a half hour with booklet 1. And then you'll open booklet 2. Bring a little plastic ruler, the little like 15-centimeter plastic ruler, perfect ruler for the exam. Bring multiple pencils. You can have colors too, but pencils are best. Just a little plastic ruler. You know what I'm talking about? The one that you get with your geometry set. Bring one. When you're drawing your asymptotes. Fine. Yeah, it's a couple people have asked me this. The answer is no. You can bring something to drink, water preferably.
I bring Jolly Brandy. If I put it in my mouth before the exam, and chew on it the whole time. Yes.
All right, moving on. So we have the square root of x, and this is interesting. How does the domain change when we apply the following transformations? So I guess the first thing would be, what is the original domain? Correct. So if I gave you the original function f of x, which happens to be the square root of x, its domain is x has to be greater than or equal to 0. If I come along and I introduce to you something called g of x, and it's a transformation of our function known as f, and there are two transformations that are occurring, but only one of those transformations impacts the domain. Which one of the transformations changes the domain? Yeah, whatever changes x changes the domain. And you don't have to write down all this detail, but we recognize now this is going to create a shift, right? Not a stretch, but a shift. And it's going to be a shift of 2, but in which direction? To the left. So shift to left. So then if you shift the function horizontally, do you shift the domain? So is it safe to say then, therefore, the new domain, and that's what people talk to me about notation for domain. I'm going to do it this way. I'm going to say the domain. I'm just going to state it clearly so they know what I'm talking about. And I'm going to use a set bracket. I'm going to say X is a proud member of the real number system. And then what is the new domain? Good. There's no reflections here. That should be okay for describe. Describe is not the problem. I think if you go back and you check the definitions, I think you're allowed to use. So if you, yeah, you could say then, I don't know. I would argue that you're telling me this is a shift here. Let me double check what the words say. Say that louder, please. Okay, so this is fine. If you're nervous about this on your exam, you can always ask me. You could take a moment and just simply state, right? If you shift a function horizontally, you also change its domain. I believe this is acceptable. Let me just double check the answer key so there's no misunderstanding. Yeah. So what they said here is their perfect answer would be, they wrote, the graph of g of x is a horizontal translations 2 units to the left of the graph f of x, which changes the domain from x is greater than 0 to x greater than or equal to -2. So I don't know if we want to take what we've written here, is this not saying the exact same thing? So I think be prepared when it says describe, I think you're allowed both. You're allowed to write it or show the notation. I take it back. If it says describe, so in a perfect world, we would simply say what? So so I would do the following if it was up to me. This would be the only thing I would write. Everything else is kind of irrelevant. Okay. G of x's domain will be shifted from the domain of f of x 2 units left. So I'm with you. The word describe suggests that you will be using words. Describe is as bad as explain. I apologize. Again, I'll say it one more time so there's no misunderstanding. When they use the word describe, you're supposed to use words to describe what's going on. I'm glad that we're doing this question. For those of you that suffered through grade 11 with me, hopefully it's paying some dividends now. This given is the original function. I'm going to go a little bit further. Like, I know it's only asking us for the vertical asymptotes, but just in case they ask you on the provincial to graph the reciprocal, and can you see why this is called the reciprocal function? So if you remember, we did the following things when you did this with me in grade 11. We know that the reciprocal of 1 is 1, and the reciprocal of -1 is -1. Those are your anchor points. I don't know. Aren't you glad that you know the difference between the grade levels? Then you're going to remember that when the original function is 0, what happens when you take the reciprocal of 0? Can you divide by 0? Hey, ask Mr. Kaminsky. Mr. Kaminsky, what happens when you divide by 0? Mr. Kaminsky, what happens when you divide by 0? There we go.
Got that right.
See? Can you guys say it with less feeling?
Oh, it said that like a song. It was pretty good actually. You got it like a little choir going on.
So we recognize then we look at this particular question. We must honor the fact that we're all going to die with a vertical asymptote, correct? So you need to bear with this. It's because it's where the y value, not the x value, where the y value, because that's the function value, it's where the y value is 0 is a problem when we're doing reciprocal. And then here you're supposed to, like, I realize I'm giving you way more detail than you need, but the vertical asymptote is when x is equal to minus 2. By the way, is there a horizontal asymptote? There is. And you're going to discover the horizontal asymptote is here. And then to save us some time, I hope you appreciate we got the blue zone. Talk about there's two different blue zones. There's the blue zone, the positive one, and the blue zone, the negative one. What happens to our function when you take the reciprocal of the values in the blue zone? It is freaky. Jaden? No, I'm doing way more than what the question's asking. I'm fearful they're going to ask you to graph a reciprocal. So if I have a value here of, let's say, 1/2, what's the reciprocal of 1/2? 2. So in the blue zone, small numbers get big, correct? So the reciprocal of 1/2 is 2, and the reciprocal of 1/3 is 3. And then we don't have to do too much, but I'm going to tell you right now, this careens really, 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 really fast. Okay? And notice that's when we're in the blue zone, because we're taking reciprocals of values that happen to be between 0 and 1. What happens when we're outside of the blue zone? Like the function now is here, isn't it? So what's the reciprocal of 2? 1/2. Perfect. And what's the reciprocal of 3? And then we understand that we're just taking the reciprocals of the y values because they're the function values. You could do 1 point specifically if this helps. This point here is 3, is it not? So, or sorry, minus 3. What's the reciprocal of minus 3? Minus 1/3. So you could put that. You don't need to, but you could. And then I think you've seen this because we've done enough rational functions because that's what this is. This is what they would be looking for if they asked you to sketch a reciprocal function. And remember, this is what we mean by reciprocal function. Yes. Well, it's interesting. In this case, it's going to be because, you ready? I think we actually, you don't normally have to find it, but if you look at f of x, can't we build f of x? Like, isn't f of x arguably down, if I look at this carefully, isn't it like down 3/2? So isn't it like minus 3/2x minus 3? That's the function. And I think you can appreciate that if I asked you to sketch y equals 1 over, I'm going to write it this way, just minus 1.5x minus 3, is that a bottom heavy function? So does it make sense then its horizontal asymptote should be y equals 0? If it's a linear function that you're taking the reciprocal of, which is what this is, then you're going to discover it has a horizontal asymptote. And then to answer Jaden's question, all you had to do to earn the 1 mark from this question is recognize that the vertical asymptote is created where the original function happens to be equal to 0. That's all you need is what I've written in red here. Thank you for being patient with me. 39 goes into 40. Woohoo! Do you have access to your calculator? No, if you use your calculator here, what mark will you get on your exam? 0, because you're cheating. How would I know?
You use it for one.
It's cheating is cheating. I don't see how it's like if you kill a person with 1 shot or many shots, they're still dead. All right. I hope that we recognize that could this be written in terms of the same base? Which base did you choose? You could do it in terms of 2 as well if you were feeling that way, but let's do it in terms of 4. So this is 4 squared, and this guy here is 4 cubed. 4 squared is being raised up to the power of x, and 4 cubed is being raised up to 2x minus 1. Bless you. Once you got the bases the same, what are you allowed to do? Play Jenga. Sounds a little bit friendlier than get rid of them. I know, it's my fault. It's my fault. What's going on with the 2 and the x? They're multiplying. So doesn't this not turn into 2x on the left? And then be careful, it's going to be 3 times 2x minus 1 on the right. Distribute, solve. And please be careful tomorrow. Take your time, show your steps, enjoy the process. You've worked hard to be here. So is this 4x on the right side? So at the end of the day, x itself is 3/4. Good. I have no idea if that's, I believe that's correct. Sure. Okay, next. There's always a question like this on the exam. They told you that x plus 3 is a factor. Can we factor the rest of this polynomial? What on earth are you gonna do? Do we need to test any values? So you already know if you divide this polynomial by x plus 3, it's already a factor because the remainder will be 0. You ready? So you're gonna create the penalty box, correct? And when you put the factor into the penalty box, what do we do to make things easier for ourselves? You're going to change the sign. Synthetic division. That's just, I don't think it is. That's a Harleyism.
Yeah, there was a question along that.
Oh, okay. And then can we put in can you be sure that you've got all the coefficients in descending order? So if you're missing one, you need to use a place value 0. But here we're good. The coefficients are 1, 2, -5, and -6. And then you got to remember, you got to build the blue line. So this is synthetic division. The first number drops unchanged. I think if you get that piece, you're going to be okay. The first number drops unchanged. Then the number below the blue line multiplies the number in the penalty box to create -3. And then you just add. What's 2 added to -3? That's -1. Then the number below the blue line multiplies the number in the penalty box. Now we're back to +3. Add the two numbers together, you generate -5. And then you allow the number below the blue line. Thank you. That changes everything. And then you take the number below the blue line, you multiply it by the number in the penalty box, and then you're super happy that it's +6. Then you're going to build this partition here. When you add the -6 to the 6, it comes out as 0, which is what we expected because we were told that it's a factor. Then I'm going to remind you the pieces that you see here from synthetic division is this is the remainder, this is the constant, this is x, and this is x squared. All right. You're now going to state the polynomial function the following manner. So p of x. You're going to state the fact that they gave you x plus 3 right at the beginning of the question. That's the binomial that we already know is a factor. And then next to it, you can write in what happened after we divided it out. Can you see these come from the synthetic division? So this is x squared minus x minus 2. Then the last thing you're going to do is you're supposed to give this in fully factored form. So our polynomial p of x could be described as x plus 3, and then you're going to factor the last trinomial, and it should be x minus 2, x plus 1. Double check that's all they're asking for. Please double check more than once. They want p of x in completely factored form. There is p of x in completely factored form. I suggest you read your questions twice and slowly. It will save you time. Worst thing is when you don't read it and you do it wrong, then you're simply losing time. All right. Oh, look at that. They even give you a line to write it on. If there's a line to write it on, can you just write it on the line? Okay. So if they give you a line like this, please put the solution there. Don't give me the chance to do that. Okay. If they've made the effort to put a line there for you, can you put it there? Okay. I love these questions. We got a couple of bounces. It's a degree 4. Is it a happy degree 4? The happy degree 4, it starts high, ends high. How much work do you need to show me? Not a lot, actually. You're going to put a 0 at minus 1, and you're going to put another 0 at plus 2. So let's put our zeros in. And then the next piece that I want from you is, can you give me the y-intercept? And if you do that, that means you're putting a 0 here and a 0 here. So if we're doing the y-intercept, it's going to be 3 times 1 squared times minus 2 squared. So please be careful with that. That's going to end up being 3 times 1 times positive 4. That's 12. And all you have to do on the exam is simply just put a ticky and then just put 12 right there so we can all see that that is indeed 12. Do not do the ticky madness and give me 12 individual tickies to get there. Okay? We know it's a degree 4 and it's a happy degree 4, and we recognize we have a bounce at minus 1. We also have a bounce at positive 2. So you just have to sketch it as follows. So we're going to come in high. We're going to bounce. We're going to launch into our y-intercept. So make sure you pass through your y-intercept. How far up you go, that's up to you. Doesn't matter to me. And then you're going to bend back down and you're going to bounce again because there's 2 bounces. And it should be. Did I do it wrong? No, I did it right. My confidence is low. This is minus 1 and this is positive 2. Jameson. As long as it's clear what the bounces are. Yeah. Are we okay to there? I think it's a fun way to earn 3 marks on this exam. Fun way. Good. Next. Again, so we ran into this one, a version of this one in the other group. I don't like these questions. They always make me angry. So did we talk about like the peanut butter allergy thing? So does one of these functions have an allergy? In fact, doesn't it have an allergy to negative numbers? So when we take a look at this here, when you start to do stuff like this, and they're simply saying, can you talk about the domain? When I take a look at the first function, g of x, isn't its domain restricted where x has to be greater than or equal to 0? What about the domain of the other function? The other function is the function where they can eat anything. Is that base to say that? This function over here, when we talk about f of x, x is simply an element of the reals. There are no restrictions for f of x. So at the end of the day, it doesn't really matter. We're supposed to give, what, 2 marks? We're supposed to find the domain for this function. Well, isn't the domain just x has to be greater than or equal to 0? Oh, see, this is why you should be in charge today. So before we do anything, we need to find f of g of x. So that's not too bad. So f of g of x is going to equal f of g of x is the square root of x. So therefore, you're going to put the square root of x in. You're then going to square it, and then you're going to subtract 4. The answer then is simply x minus 4. Okay. But then you have to state the domain. So when you do this, you could put x minus 4 here. Does it have a space for, that's funny, they asked for the domain, but they don't give you a line for it. Comma, where x itself has to be greater than or equal to 0. Yeah, better. So when you're doing a composition or whenever you're working with multiple functions and one function has a restricted domain, be sure to honor that restriction in your solution, please. Okay, just because one person can eat everything doesn't mean everybody else can. Are we okay with that? All right. That's 43. Look for that. They love this. The last few exams, this has shown up, right? If one of them is restricted. Oh, it's not build a bear, it's build a radical function. I did ask my daughter if she still had her build a bear. It's true. I could have flushed it. No, we have memories. Okay. First things first. This is good. What type of function is it? So those are called radical functions. Anything begins with RA. Sideways. Oh, conjugate. Oh. It is its own language. So we appreciate this is the father of all radical functions, the square root of x. So it definitely looks like if we were going to write it in words, you don't have to write it in words, but what's happened to our poor square root function? Okay, so we got a vertical stretch by what factor? Okay, vertical stretch by a factor of 2. Love it. What else has happened to our poor square root function? It's going backwards. How do we make that happen? Reflection. Is it in terms of a horizontal? Don't we call it reflected over something? I know. But it's reflected over which axis? So we reflected over the y-axis, but I'm with Sam. It's like it's changing the x, right? It's changing the x. Is there any other changes? Yeah, it's a shift. Can we see there's a shift here? Just a single shift, thank goodness. So can we say it's a horizontal shift? And I guess we would say 1 unit which way? Right, okay. Can we translate this into the transformations that are required? So we're going to do reflections first. Reflections first, stretches second, shifts last. So you're going to tell me f of x is equal to, well, I guess I'm going to put the 2 here because there's a vertical stretch by a factor of 2. So it's 2 square root of, and then isn't it minus, no, careful, minus bracket x minus 1 in bracket. That is the correct solution. We've got the correct shift 1 step to the right. We've got the correct reflection over the y-axis, and we have the correct vertical stretch by a factor of 2. Bet you this thing's worth 3 marks. Let's find out. Is it? Okay. I wonder how they're marking it. This one makes sense to me. Okay, good. Okay, next. Now, explain why the graph log to the base 2 of x has no y-intercept. Explain why. So I think this, I like Jaden's more. I think most people would say the argument of a logarithm can never be equal to 0. They're not really explaining to me why. They're just telling me a fact, and that's okay. Kind of like what Jaden said. So we'll give you both. So Jade, or you just know that the argument of a logarithm can never be 0. But what Jaden said, I think, is a bit more powerful. He said, but it's not words. That's the tough part, right? He said that there's 2 to the power of y can never equal 0 because he unraveled the logarithm. And can you find a value of y that this is going to happen for? Is there an exponent that helps you generate? No, because 2 to the power of 1 is 2. I understand what you mean. That's true. The other way is okay. I think sometimes too, I'm going to remind you of this because someone had a good conversation with me earlier. When we draw logarithmic functions, remember they always have an asymptote, but it's a vertical asymptote, right? So they have a vertical asymptote. So I think that feels like a wall to me. So this is like y equals log x. When we draw exponential functions, they also have an asymptote. For me, though, it's like the floor. So when you draw an exponential function, it looks like this. I bring this up because it's something that I'm concerned about what they may do to you on the test or on the exam. If they decide to say, hey, y equals log of, and they do, let's say, something like x minus 3 plus 4, where does the asymptote go in this circumstance? Are we okay with that? Since it's a vertical asymptote where it's like x is equal to 0, and they apply a horizontal change, can you see then you'd get a new vertical asymptote? Your new vertical asymptote at x is equal to positive 3. When you're working with an exponential function, so let's say we decide to draw y is equal to the x minus 3 plus 4, what happens there in terms of its asymptote? Remember, exponential functions don't have a wall, they have the floor. And what happens to the floor if we decide to apply these transformations? And it's just going to go up 4. So here you're going to get a horizontal asymptote when y tries to be equal to 4. Be careful of that. So exponentials have a floor. They have a horizontal asymptote, and how it changes based on the vertical shift. Logarithmic functions, they change their asymptote based on their shift left or right. Okay. Next. Woo! Do you know your exact values on the circle?
No. 5 that don't get that out, and it will save.
It will. It will absolutely will save you. Well, you're releasing RAM, right? Sorry, computer comment. Your readily accessible memory is released so you can think about other things. Question. here we go. Let's start the madness. So first things first, if I want to go to the sine of minus pi by 3, the sine of minus pi by 3 is probably going to be minus the square root 3 over 2 squared. Okay. 17 pi by 6. I hate 17, but is it okay if we take away 2 pi? And by that I mean 12 pi by 6. So isn't the coterminal angle here 5 pi by 6? So what's the cosine of 5 pi by 6? It's got to be negative root 3 over 2. And then secant of pi by 6, I hate secant. And in a perfect world, secant should go with sine, but it's not a perfect world. So you're going to look up the cosine of pi by 6. And what is the cosine of pi by 6? Should be 1/2. So therefore, what is the secant of pi by 6? Is it? You know what it was? I just didn't want to have to deal with root 3 over 2. Better? I'd like to say I was just seeing if you were paying attention, but we know that's a lie. And then we're going to multiply it by, and I'm not having a good week because this morning was rough too. So the standard to get a shirt might be lower than usual. Okay. Okay, here we go. Can you get... All right, moving on. Maybe I'll save all the money from the shirts and buy myself some socks instead. All right, this gives us 3 over 4, correct? This is going to be minus 1. So isn't the answer minus 1/4? It's also worth like 3 marks. And it's interesting too, because if you just give the fractions, the 3 correct fractions, you get 3 marks. And then if you don't do the number correctly, you lose a 1/2 mark for arithmetic. So it's a weird question. So if you just give the 3 fractions, so if you state this fraction, and this fraction correctly, you get 3 marks. But if you don't get to minus 1/4, you just lose 1/2 a mark. I don't know. That's 46. Here we go. Next. Ooh. So in order to have a point of discontinuity, what needs to happen? Something needs to cancel, which suggests... So if we factor out the x, we're left with, I guess, x minus 3. So therefore, we get our removal, which means the POD happens when x equals 0. But you're supposed to give me the coordinates of the POD. Once we go back to the function after the removal, can we just substitute 0 in? So now you can celebrate that your POD lives at 0, comma, minus 3. One mark, 1 page. Oh, they're just mean. Just mean. You can only add functions together when they have a shared domain. You can only add functions. Actually, you can't. You can only add, multiply, subtract, and divide where they have a shared domain. Can you see these functions only have a shared domain from here to, I guess, infinity? Can we see that? Yeah. All right, we're supposed to be adding these things together. So what I would do is the following. We choose x. We'll use the table to help us figure out what f of x is. We'll use we'll use the sketch to find out what f of x is. We'll use the sketch to find out what g of x is. And h of x is simply the sum. So if we start at this moment here, this is when x happens to be -2. Can you see the first function is -3 and the second function is +3? Are we okay with those coordinates? So here, this is the coordinate -2 and -3. This is 2 and +3. Next, let's move to the next dot. The next dot is here. When x is -1, the first function is also -1. And then the quadratic function happens to be 0. I think I'm just going to do a couple more points. I don't think you need to do a ton more. Let's go when x is 0. When x is 0, the first function is +1. The second function is actually -1. Let's go on to another one. Let's go to 1. When we go to +1, this first function is 3. The second function is in fact 0. Let's just do one more. We do one more at 2. So we're looking for the function values at 2. When you put 2 in, the linear function happens to be 5. The quadratic function happens to be 3. It's probably more coordinates than I need, but now we can do the sum. We're supposed to be adding them together. So we get 0, -1, 0, 3, and 8. Make sure you plot these points as best as you can. So at -2, you get 0. At -1, you get -1. And please appreciate you're sketching these x values with these function values. When you put 0 in, you get 0 out. When you put 1 in, you get 3 out. I don't know if we'll get to the next one. If you put 2 in, do we get to 8? Oh, that's handy. And then be careful that you make sure you only sketch where the domain is shared between the two functions. And do we get to put an arrowhead on? The answer is yes. Because if you look back here at the beginning, is there not arrowheads here on both sides? So make sure you honor that. Next. We're looking for exact value for tangent theta. You're told that cosecant theta, and again, you're just going to take that right away and recognize that they're discussing sine theta, and sine theta is going to be minus the square root of 7 all over 4. You're also told that cosine theta is greater than 0, so maybe we need to acknowledge what that means. Sine theta is negative in quadrants 3 and 4. cosine theta is positive in 1 and 4. Can you see then our solution needs to be in quadrant 4? Okay. Then what I want you to do is ignore what quadrant you're in and just go back to grade 10 trigonometry. So you're just going to draw a triangle. You're going to put theta here. I don't care about plus or minus anymore. Opposite is root 7 because it's sine. It's opposite over hypotenuse. Therefore, you're going to have to do some Pythagoras to find the missing side. Careful, it's going to be like x squared plus the square root of 7 squared equals 4 squared. Is it 9? And then when we take the square root of both sides, are we at this point that we recognize if you have something squared, it suggests there's probably 2 answers? And in this case here, there are likely 2 answers. X could be equal to plus or minus 3. But then we discover which one we're going to use in a moment because what quadrant are we in? 4. And then we know, so can I just go over here and just put 3 into my triangle? That's the easiest way to do it. Now can I describe tangent theta from the triangle? Isn't it opposite over adjacent? So it's square root of 7 all over 3. And then because we're in quadrant 4, you better make sure there's a minus sign in front. Good. Oh. Any questions? Ask me anything you want. Okay, hold on. Where is it from? Is it from an exam? No, sit. I can find the exam. And then we can share it with everybody. Hey, look how many views I got. 28, 27, 34, 32, 37. You're a subscriber? I'm gonna use hashtags? Which exam? Wow. First book or second book? Oh, I like this. This one? Do you read? Thank you for asking me. Let's not talk. We're not gonna live in the past. Honestly, I don't remember. I don't. It was not as high as I wanted it. Let's put it that way. Here's the question from a few years back. Let's talk about this. You guys are seeing it. Some of you are seeing it for the first time. All right, on that happy note, let's get started. Can you appreciate, though, we're looking at the reciprocal. So first thing that jumps out to me is, couple things. Can you take the reciprocal at where the function value is 0? No, so if this ever changes color, which would be nice, thank you. So this, oh, it's decided that's the way it's going to be. Fine. So can you see you're going to get a vertical asymptote here? It's supposed to be red, but it won't change for me. At x is equal to +1, you have a vertical asymptote. Okay. What other things can we grab onto? Yeah, so this is interesting too. What all along here, this horizontal line, what's going to happen between here and here? And when you take the reciprocal, nothing. It just stays the same. They're all invariant points, aren't they? All right, now we got, it's not going to change for me, it's fine. Now we got like the blue zone. What happens in the blue zone? So these values are like a half and a third and a tenth and so forth. What happens when we take the reciprocal? They get huge. Okay. So this is going to bend and it's going to approach positive infinity based on what's happening in this little section here. Then what happens in this other blue zone down here? Well, again, we've got an invariant point at -1. So what's going on between here and here when we notice that these values are small? Is it safe to say it's just going to bend and look like this? Okay. Ask me anything. This is honestly the last time you will see me before the exam. You ask if you're ready to go. Which exam is it? Same exam? Sure. Same exam question, the one before. This one? Okay. I guess this is a good place for us to end the course. Okay, you ready? If cotangent theta is equal to -1/3, what's true about tangent theta? Is -3/1. And could we draw that right triangle right now if we don't care if it's positive or negative? Yeah. And then in this case, if I don't care if it's positive or negative, isn't the opposite 3 and this is 1? Okay. And then now we need to use Pythagoras to find out the length of the hypotenuse. So it's going to be 3 squared plus 1 squared equals, we're going to call it r squared because it feels like radius of a circle. This is going to be 10 is equal to r squared. So this is the square root of 10. And then in order to describe sine theta, it's supposed to be opposite over hypotenuse. So this is supposed to be 3 over the square root of 10. But before you celebrate, is it positive or is it negative? Perfect. So it's positive. And then I don't think you have to rationalize on the exam. So you can leave it like that. If you do choose to rationalize, which I'll probably just do out of habit, it just turns into 3 square roots of 10 all over 10. Okay. All right, so what are we doing tonight? There's a hockey game on. You can watch that. You should be resting your brains tonight. Go for a walk, take your dog for a walk, take your parents for a walk, get outside, enjoy the weather. Do not bring a graphing calculator with you tomorrow. I will not let you use it. Yeah, you can bring coffee. You can bring water. You can bring tea.
Where do you see the SRT?
Well, if you go to Finsky, if you go into Finsky, our Finsky, so the answer key right here, in the pinned items, and if you click, it will just launch. It should launch. And then you just go to grade 12 pre-calculus.
And then these are all the exams, and then all the answer keys are here in the monthly guides.
Also, it's 20%.
Hot mic, hot mic.